So today, thank you so much again, Wesley, for inviting me to talk today in this design series. As you heard, my background is not in design, but I'm here to talk about how design can help us solve the plastic pollution issue. I want to talk about the fate of plastics and promoting responsibility through design. I'm the education director at Algalita, which is a local nonprofit here in Long Beach, California, dedicated to understanding the issue of plastic pollution and educating people about it. Turn this volume down a little bit. So this video here is taken about a third of the way between California and Japan. In one of the 5 main accumulation zones that occur in our planet's oceans. And this is where a lot of the plastic that we have produced over the years has ended up. And I wanted to start off with this because it really puts us, or it puts me in this space of perspective around what the issue looks like and means for the planet. And so I wanted to start off with that because it's just kind of different and immersive, I feel. So you can see the plastics floating in the surface water. This is a big tangled net or a piece of fishing rope. But you can see all sorts of different plastic items like this bottle here. This cone-shaped item is an eel trap. And what you can't see too well, but in some shots of the video, you can see the small microplastics, which are, a lot of them are so small that you need a microscope to see them. And this is essentially what our oceans are becoming to look like. We call this plastic soup. It's this concoction of plastic items and the marine life that should be living there. So today my goal is to help you understand the complexities of plastic pollution and this broader plastics issue, so that you as a designer can help us or help contribute to the solutions, whether that's directly or indirectly. And so the way that I'm going to do this is talk a little bit about the context of this issue, help put it in a space where we can start to address the situation with real solutions. And then I want to talk a little bit about some of the design challenges that have been identified around the mainly plastic products that we use in our everyday lives. And then I want to talk about some real world solution critiques, which is going to be an activity that we'll do together. So I want to start by saying a little note about the difference between impactful design and responsible design, as I see it. Of course, design is such a broad thing, but what I've seen through my work of looking at plastics pollution and how it presents in our world, we really have to think about how all of our solutions to problems that we're trying to solve can have broad, massive impacts on so many people. And so, of course, we have to be responsible with this power that we have when we bring a new idea into the world. And I also want to say that what I'm going to be talking about today is not the full story. I'm fully aware that this issue of plastic pollution is deeply rooted in our policies and in our economics and our access to fossil fuels. And so what I'm going to be talking about today is really just one part of the story. The part of the story that involves how we're creating the products that we fill our world with. Where a lot of the times when I'm giving presentations, I'm talking about how can we reduce the amount of plastics that are even being produced? How can we design different systems, different societies, different economic systems even to help us combat this issue, because it is deeply rooted in the way that we've structured our economics and our politics. So I want to preface with that because I'm aware that this is a big part of the situation, and today I'm going to try to focus on design, which I find really exciting. And I also want to let everybody know that if there's any questions, please put them in the chat or even raise your hand. And I can try to get to them in real time, but we'll also have time for questions at the end. All right, so I want to start with a little activity. So I'm going to show a series of images, and you can either think of the word or phrase or write it down in the chat, the first word or phrase that you think of with each of these images. I'll give you about 10 seconds for each one, and then show you what my word is. All right, so here we go. Just gotta re-navigate to my slides here. Okay. All right, so I chose the word globalization. This is a young girl in a community in Surabaya, Indonesia. That's in the paper recycling, their paper recycling community. All right, my word is consumerism. I put designer's miracle because plastics are moldable, shapeable into almost infinite forms, if not infinite. Plastics are often associated with safety. And this is the last one here. This is a sample taken by our expedition crew in 2019. This is about 30 minutes of dragging a net in the water. My word is durable this time because plastics are one of these materials that nature can't break down. And so therefore it has a lot of benefits, but also it's extremely problematic for the environment. All right, so thank you all for contributing to that. Okay, so to talk a little bit about the context, I want to start with one of the main points, which is that plastics are fossil fuels. Plastic is made from oil and natural gas, and therefore their use perpetuates a lot of the social and environmental issues associated with our reliance on fossil fuels. Sorry, my slide isn't working. So I want to take us back in time and look at some of look at the historical trends of carbon dioxide in our atmosphere. Here we can see this is 800,000 years before present. And the speech bubble here points to the first urban civilization, first human civilization about 6,000 years ago. And we can see all the way on the right side of the graph, the CO2 concentrations that we're at today, which are way above the stable fluctuation before humans. This zooms in a little bit more to 10,000 years. And again, pinpointing the first urban civilization. and looking at the massive increase in and rapid increase in carbon dioxide concentration in our atmosphere. And this zooms in even further. Here we see where fossil fuels first started to be used in large amounts by human civilization, and the end of the World War II, and this is when the plastics market really expanded rapidly. Plastics were used during the war, and after the war, they started to be used in household as common goods. I wanted to point out a few of the major points in time when different types of plastics were being invented. Here we can see the earliest plastics, Parkesine and Bakelite, cellophane, and then in the 1930s, between the 1950s, this is when the plastics that we know today were being invented and created. So essentially, this plastic material that was created by humans was ironically made the first incentives for making plastics was to find an alternative for naturally occurring polymers like ivory. And so plastics were really seen as this miracle material that could be shaped into so many different forms. It was very durable. It wouldn't break. It allowed for huge advances in our society. We have to remember that where we are today is a result of our access to fossil fuels, which essentially have provided us with energy and materials to accomplish the things that we do today. And petrochemicals became a huge market as the fossil fuel industry started to look at how they could profit from the waste products of oil extraction for energy. There's all sorts of different types of molecules that come out of the ground when you're pumping for or drilling for oil or fracking natural gas. And so essentially they're capitalizing on all of that material and using it to make all sorts of different products, from solvents to pesticides, fertilizers, detergents, cosmetics, dyes, and of course plastics. So the first form that plastics take when they're made out of natural gas is actually these pellets that you see littered on the ground here. These are the first, these are essentially the feedstock that companies will buy to make plastic products. And they do get littered into the environment as well, although I won't go into this today. So plastics and other petrochemicals have become the plan B for fossil fuel industries as the world moves away from fossil fuels and moves towards renewable energy. And this is really seen in the massive build out that's occurring across the United States, namely in the Gulf Coast and along the Ohio River Valley. This is a massive facility that's being built in Beaver County, Pennsylvania, which will be produced purely for the production of polyethylene plastic. And this processing of fossil fuels into plastics is extremely energy intensive, releasing huge amounts of greenhouse gases. So a report that was recently produced by the Center for International Environmental Law predicts that with the present trajectory, plastic production alone could consume more than 12% of the Earth's remaining carbon budget by 2050. So this graph is showing annual emissions from plastic production and the incineration of that plastic. Plastic is a fossil fuel, and when it's burned as a waste processing method, it also releases that carbon back into the atmosphere as well as other toxins. And so my point here is to show that plastics are extremely problematic, not just because they're ending up in the environment, which is the first thing that we've all learned about plastic pollution, but more so, this is a human health and human rights issue that's directly connected with the climate issue that we're facing today. The second point that I want to share is that plastics don't fit into nature's recycling systems or into our recycling systems. Over the years that plastics have been produced and brought into our world, we've been led to believe that plastics are recyclable. And here in the United States, highly developed country, we've been able to believe that story because we are not where our waste ends up. We throw our trash away, and most of us don't know where our way is. It's somewhere on this planet, unless the plastic gets burned. And for a long time, up until just 2019, China was buying huge amounts of the world's plastic waste. This picture is taken in Indonesia as well. This shows all of the scrap plastic that was put into paper recycling containers to be, it was basically contaminating the paper recycling stream. And this plastic is not recyclable. We'll talk a little bit about why in a moment. But recycling plastics is extremely challenging and therefore not profitable. So why is that? So I want to show this diagram first that shows the different materials that end up in our waste stream here in the United States. And this is from 2017. This data takes forever to be released. But we can see that plastics make up about 14% of the waste stream. This is by weight. Plastics are extremely light, so by volume, they make up a much bigger percentage. When we look at the diagram on the right side, we can see that plastics are one of the only materials that we use that is not infinitely recyclable or compostable. It's not a natural material that Earth creates and knows how to process, but it's also not infinitely recyclable because it melts at a very low temperature. And so all of the contamination that the plastic is combined with, whether that's dirt or grease or food contamination or residual material from the product, or maybe the plastics actually combined with other materials, which is extremely common, the recycling process becomes extremely challenging because you actually have to separate those materials to be able to recycle them properly. So overall, less than 10% of plastics that have ever been produced have been recycled even once. There's no information about plastics that have been recycled more than one time because that literally almost never happens. We've been made to believe that plastics are recyclable by stories told by the industry, and this was done very intentionally. There's a lot of data that has recently come out, memos and reports from the industry showing that they were very aware that plastics were not going to be economically recyclable. And so they made it their advertise and took the reins and basically tried to make people believe that they were the problem as litter bugs, or put your trash in the trash can or put it in the recycling bin. And the only reason why that worked is because we were able to export that waste to other parts of the world. So a few of the reasons why plastics are not recyclable, just to recap. One is that, which I haven't talked about yet, is that virgin plastics are very cheap because of the oil subsidies that we have, and the huge supply of natural gas, which we currently have due to the fracking industry. it's much more expensive to collect, sort, wash, and then reprocess plastic than it is to make a new plastic product from virgin oil or natural gas. Secondly, plastics are technically recyclable. All of these plastics that you see in this picture most likely are technically recyclable in a lab. You could bring them to a lab and melt them down and mold them into something new. But when we look at the scale of how much plastics are being used and produced, and we look at the complexity of actually recycling these plastics, it becomes essentially not possible to do economically. You can't make money from it. The third thing, which is really important to talk about today, is that a lot of these products are actually designed to not be recyclable. They're designed without recyclability in mind. And we'll talk a lot more about that through the presentation. And then lastly, plastics aren't infinitely recyclable. Every time they get heated, the polymer degrades a bit. And so there's a limit to how many times you can recycle plastic versus with metal or glass. It's infinitely recyclable. So a few of the designs that are essentially recycling nightmares that we see commonly on our grocery store shelves are what you can see here. And these aren't all of them, of course, these are just a few. But one of the biggest challenges are when two different materials are combined together. And this doesn't mean just plastics and metal are combined, but different types of plastics. There are thousands of different types of polymers out there. There are 6 main categories of plastics that we use in most food packaging. But there's many different types of plastics. And a lot of the time, there are multiple types of plastics combined in a single product. For example, you can see here this chip bag. These are cornflakes or something like that. Or sorry, cereal bag. Cereal bags, I've learned, can have up to 9 different layers of different plastics in them. And the reason for that is because each layer serves a different purpose, whether it's stiffness for the bag, or it's keeping oxygen out, or maybe it's a water barrier. They all have different functionalities. Same thing with the chip bag. We have an aluminum lining on the inside of the chip bag. This is mylar. And the reason for this is it drastically reduces oxygen migrating into and out of the bag, which keeps the chips fresh for longer. So this is a design choice and an engineering choice that makes the functionality of the product better, but drastically limits the recyclability of the product. And so essentially plastics are, as our founder says, the lubrication of capitalism, because without plastics, we wouldn't have processed foods, and we wouldn't be able to feed the billions of people on our planet in the way that we do today. So this isn't an easy problem to solve, which is why I'm hopefully here today to help you understand some of these complexities so you can think about them throughout your design careers. So a few other design challenges are things like these shrink sleeves, which are challenging because the sorting machinery sees the one plastic that's in the sleeve, but the bulk of the plastic in that product is actually what the bottle is made out of. And so this contaminates the one type of plastic stream with the other. Now, plastics can't all be recycled together. They have to be separated very, very well to actually be recyclable and to be made into a new product that actually has value and is safe to use. So all of these are different examples of different types of materials being connected together in ways that are very challenging to separate. The separability is not designed into the product. So today, if it's not a number 1 or number 2 bottle, and these are types of plastics, they have extremely low chance of being recycled. And these are just some examples of the plastics that we see. These are called fast-moving consumer goods that are lining our grocery shelves. But we also have a huge amount of other items that fill our world that are made out of plastic that we don't necessarily identify as plastic. And these are just a few of the examples from acrylic paint that we use to paint our houses with, sports clothing and backpacks and all sorts of accessories, balloons, cans are lined with plastics, carpet, chewing gum, erasers, Elmer's glue, fake leather, floss, glitter, nail polish, spandex, tea bags. The list goes on and on and on. And so this presents huge opportunity for designing plastics out of our lives again, or at least finding ways to use plastics responsibly. So I want to do a quick activity so everybody can stand up and stretch, or maybe you have a plastic item that's right next to you already. But see if you can identify a plastic item that's near you in your room that you can bring to the table. I've got two examples here. This is a sunscreen and a CD. Maybe it's on your head, glasses, or earbuds. And hold it up so I can see what you guys have. And if you don't have your camera on, that's totally fine. So the activity is to think about this item that you have in your hand. I want everybody to ask themselves, what is the function of this item? What are the components or materials that make this item up? Oftentimes, this is going to be not identifiable because it's not going to be noted on the item what it's made out of. And this is one of the big opportunities that we see in the policy space is having companies note what their products are made of. What are the ingredients in their products? Because those ingredients can have human health impacts, etc. Think about is this item designed for single use or reuse? Is it designed for repair, recyclability, planned obsolescence, longevity? Planned obsolescence is a term that means that a product is actually designed to lose its value after a certain time period. So there's a few types of planned obsolescence. One is planned obsolescence of desirability, which is what we see in fashion. There's a new fashion that comes out that makes the old one obsolete. There's planned obsolescence of functionality or quality. So it actually is designed to break after a certain point. Maybe there's a certain part on it that's really flimsy and will break before everything else does. So there's a few different kinds of planned obsolescence. And then lastly, I want you to think about, do you think this product was designed with end of life in mind? And why or why not? Was this a design choice, or was it just that they didn't think about it? What happens to this product when you're done using it? Is there a way for it to be recycled or returned back to the earth in a way that isn't harmful? So today, with this topic of plastic pollution, one of the big things that I would love to see is for designers, whether they're coming up with products or whether they're coming up with new systems, any type of solution, we need to think about the unintended consequences of the production of that product as part of the responsibility of making that product in the first place. Okay, so we're almost done with the context here, and then I'm going to talk a little bit about some more of the design challenges that we're seeing. So essentially with the plastics industry and the fossil fuel industry, they are predicting and planning for the production of much more plastic, increasing plastic production by about 40% over the next 10 years through this massive build out here in the United States and in other parts of the world. And recycling is not a part of that equation. The recycling infrastructure in the United States hasn't changed. It's not funded. And essentially, this is going to have to change through policies that put the financial burden to make this happen onto those companies. And a lot of these companies are looking to incineration and what they're calling advanced recycling as solutions to these unrecyclable products. Incineration is burning the plastics, which often happens in open fields in many parts of the world. The picture that I showed in the beginning with the little girl standing in the field with the yellow dress, that field of plastic that she was standing on gets burned on a daily basis in her community, just right into the air. So this is a massive human health issue, human rights issue. Now, advanced recycling is technology that is being invested in heavily by the plastics industry currently. And it's essentially a suite of different technologies that incinerate plastic, but in the absence of oxygen, which produces fuels and other molecules. And these fuels can then be burned. And in a few cases, there are some prototypes that have been able to make new feedstock material to make, for example, new plastics. But this is also extremely energy intensive. And in the movement, we don't see this as a true solution. So my warning to humankind, and particularly people coming up with solutions to this issue, is that we really need to think about the unintended consequences of our solutions. We're seeing huge amounts of ideas come into play to solve this issue. And a lot of them are just perpetuating wasteful behavior. They're not actually helping us be more responsible with our materials and with our products. And so we really need to take the time to research and understand the communities and people and the environments that will be impacted by these things that we're bringing into the world. When the people were back in the 30s and 40s and even earlier were inventing plastics as this material that nature couldn't break down, that would last for huge amounts of time and was, this new thing that they didn't fully understand. But they were not imagining, or they could not imagine that, what we would be dealing with today as a consequence of this new invention. And so I think we really need to take on the responsibility of trying to imagine the futures that our products or our solutions or our designs create, to make sure that we don't just make more problems as we're trying to solve this one. So just to expand on that a little bit, one thing that I would love to see is for designers to bring different people to the table when they're designing their products. Scientists, recyclers, biologists, all together, assessing the solution or the design that's being brought forward, and to think about how it's going to impact their specific fields, or they're experts on their part. But I'm not an expert on design, but I would say I'm an expert on plastic pollution, so we can share that information and help each other get to the best result or the best solution. We need to create a culture that also starts to look at plastic differently as a material that is extremely important for the way that we live our lives today. Imagine going to a hospital and saying, please don't use any plastic when you're treating me. That would not fly, right? So, but we have to start thinking about what are the appropriate situations for us to use plastics. And we need to start imagining alternatives to the situation, to the solutions that we're so used to today. You know, we go into a grocery store and we don't even think about the fact that every single thing in that grocery store is covered in plastic. But it doesn't necessarily have to be like that, right? We have to start picturing our future less plasticized, because we can't go on with how it is today. Some of the pictures that I've shared so far give you a sense of why. But we're finding plastics in not just our oceans, but we're finding them accumulating in our soils, and we are breathing them daily in our homes. They are surrounding us on our skin all the time because we're wearing plastic clothing and wearing plastic devices. And we're finding plastics and the chemicals that are in plastics in the human body, in human feces, and the list goes on. In placentas, pregnant women's placentas, it's infiltrating our bodies and our planet. So we can't go on this path. And I think that because plastic is so ubiquitous in our world, there's so many opportunities for people, whatever you are doing, whatever space you're designing in, to contribute to the solutions, which is why I'm very excited to be able to talk to you today. So we really need to consider, when we're creating these solutions, not just the products themselves in a vacuum, but we need to consider the infrastructure that has to go with them. There's been a lot of solutions that have been presented around plastics that are great, but they don't work because the infrastructure is not there. For example, bioplastics. Bioplastics are plastics that are made from things other than fossil fuels, from plant material. But they currently don't work in our infrastructure because we don't have massive composting systems here in Long Beach. We don't have a green bin that we put our green waste into. So we can't rely on bioplastics. So we have to think about our infrastructure, our human behavior, how do humans act, and how do we make our buying decisions, right? Design is important in this solution to build full systems where we can be more responsible with our materials and products that we're using, and with our spaces that we're in. And I can elaborate on that for a long time, but I'll move on. All right, so some of the design challenges, I want to dive into some of these exciting things that are happening today, and summarize what the design solutions are from my perspective. Essentially, we need to design a culture that moves away from overconsumption and irresponsible use of plastics. But how do we actually do that? So my first design challenge that I want to present is designing based on biocompatibility. Plastics are not compatible with nature. Nature does not know how to break them down. Bacteria might evolve in a few million years to be able to break it down, but that's not going to happen anytime soon to help us. So we need to see how we can start to create materials, alternatives to plastics, that are bio-based and that are safe and healthy and okay for humans to use. We need to create renewable systems and regenerative systems. which nature is fantastic at already. So how can we learn from nature and create solutions that are more beautiful, more exciting? We can get super excited about them because they're not degrading our environment. They're not degrading our future or our homes, right, by off-gassing. For example, polyurethane is what we use to make faux leather. It's a particularly toxic type of plastic that, and I should explain, not all plastics are toxic in themselves because of the polymer structure. They're inert. Things don't react with them, and that's why they don't break down. But a lot of the plastics that we use, the monomers, the components that are put together to make the polymer, those can be hazardous to human health, and they can separate from the larger material and enter your body. And a lot of additives that are put into plastics to change the way that they look or feel, or maybe that makes them more flexible, more durable, et cetera, these are often extremely hazardous to human health as well. So how do we, for example, this is, instead of using polyurethane to make fake leather shoes, using pineapple tops. This company, Piñatex, is making an alternative leather material from the tops of pineapple, so this fiber. And this is really incredible, not just because it's creating this alternative material that is regenerative, but it's providing communities who are pineapple farmers with an additional market to participate in. They're able to maximize their crop. When before they were either composting or replanting those tops, now they can also use them to make a new product or more profit. Another example of this is this company Footprint, which is essentially taking plant fibers to make all sorts of different containers and products for replacing plastic items that we would see in the grocery store today. Everything from dairy cups to meat trays to egg cartons to freezer meals, the meals that you just pop in your oven and cook. What they've really done is focus on this plant molding technology is not so new, but their main thing is looking at the barrier technology. So plastics are a water barrier, right? So when you put something in plastic, it doesn't leak through, it doesn't get soggy, which paper does. And so their technology, which is proprietary still, is PFAS free. So PFAS is a chemical that's commonly used to protect paper, make it more water and oil resistant. This is another very harmful chemical that is surrounding us in our daily lives. And so they're coming up with alternatives to that. They don't have information on their barrier technology or the health and safety of it, other than saying that it is safe. So this is something I'm definitely going to be keeping my eye on. But this leads me to say that we do need alternative solutions. We need massive amounts of innovation, and we need to support each other in getting there. So I'm, trusting this company so far and sharing with you today in the hopes that their technology is truly what they say it is. But I'm also very wary of that, and I'm going to critique them if I find out that it's not. So we need to, finding solutions to this is not easy, especially in our extremely, competitive environment that we live today. Like, this is hard stuff to figure out, but there's a lot of cool things that are happening. The second design challenge that I want to share is designing durable goods for longevity and infrastructure to match that. So the first design challenge was all about fast-moving consumer goods, right? Which there are solutions for packaging that, maybe are reusable containers and things like that, which we'll talk about in a little bit too. But we have a whole new set of design challenges when we're looking at these durable goods, whether it's that watch that you shared about, or it's the office chair that we're sitting on, it's the furniture in our homes, it's our homes themselves. So how do we design these goods to be long lasting? How do we design them to be durable, to be recyclable, customizable, and safe to use? One of my favorite examples is this steel case office chair. It's not perfect, but it's pretty cool. So this office chair is designed so that you can take it apart with a simple tool. All the different components can be separated and therefore recycled and dealt with properly. This company is using recycled materials to make their products, but it goes beyond that. It's also customizable. You can get a different type of fabric to cover your chair. You can get a certain color, you can get different types of textiles. And so it's very customizable, which is cool for the customer, right? But it's also cool because it's modular. And if you wear out just the seat, you can get a new seat without having to get a whole new chair. And you can do all sorts of different things to lengthen the lifespan of your product and to have more control over how the product gets repaired, reused, etc. So one way to think about these first two design challenges with or two examples with the biocompatibility and the design for durable goods to be more circular is this butterfly diagram here posed by the Ellen MacArthur Foundation, which focuses on circular economy. And essentially what I want to point out on this diagram is that there are two lobes. There's the left side, which is the green side, and the right side, which is the blue side. So we see that on the left side, these are the biological components of a product or of a biological system, right? So you can have materials that are moving through this space from the production phase to the service provider to the consumer, who then recycles that material back into the biosphere through composting, through different types of methods that essentially essentially composting. And then we have the technical nutrient side, which is for everything that's not of biological nature, metals, glass, plastics, essentially. So how can we design products to move through these two lobes separately to maximize their recyclability? And the third design challenge that I want to share today is about finding alternative distribution systems for fast-moving consumer goods. So how can we, this is one of the biggest challenges because plastics are so optimal in our current world in an economic sense, in a design sense. They're lightweight, they're thin, they're moldable, you can brand them all sorts of different ways. They're unbeatable in the industry. So we do need to find alternatives to this. And I've shared a few alternatives already, and we'll talk about a few more as well, but there's a huge amount of space for innovation here. One example that I want to point out is this disappearing package, which is essentially products without packaging at all. So on the left side, you can see the Tide Pods that instead of being in a box or a bag, they're in a roll of perforated pods, and the marketing is directly on the pods. They're rolled up in a cylinder. So this does a few things. One is that it eliminates the need for the packaging. Of course, this is not a perfect solution because Tide Pods dissolve in water, so you still got to transport them somehow. But once you're done with your last pod, you have nothing to throw away. And what's cool about this too is that you actually get more marketing real estate on the product. You can see this in the second example as well. So there's more space to advertise for your product in the way that they've done this here. Another example is this Miwa company, which is, I believe, in Eastern Europe. And this is a different modular system for grocery stores. It's a bulk system, but it's optimized in a lot of different ways. So these capsules are washable and will, once they're empty, they get sent back to the distribution center to be washed and refilled. The customer takes a Miwa cup that has a sensor on it, a smart sensor, that identifies the product that it's being filled with and how much, and then can pay directly from your phone. So this is an alternative system for delivering food to people in grocery stores, as opposed to having everything packaged separately. So there's some really cool examples for how people are addressing this issue. This was an award winner in the challenge a few years ago. So how can we go from packaged products or products packaged in plastic to products packaged in biocompatible materials to maybe no packaging at all, right? Of course, it's going to differ depending on the product and the needs required. But this is where these design constraints come in, and how can we work around these to come up with truly innovative and super cool solutions that work not just for pocketbooks, but for people as well. I want to share one last example. I talked a little bit about plastic clothing and the fact that we're breathing plastics. So we have huge amounts of the textile industry are being taken over by plastic textiles, whether that's polyester, acrylic, nylon, and the list goes on. These textiles are being used for clothing, carpets, furniture, all sorts of different spaces around us and in our cars and in our homes. And this is a huge part of the plastics issue, is microfiber pollution. So you can see on the bottom right-hand image, these microfibers, they're extremely small, fine fibers that if you can pinch them off your shirt to try to see them, hold them up against the light. And those are some of the bigger pieces. They get really, really, really small. And so one big design challenge is, how do we address this issue? There are, of course, solutions being suggested around filtering, clothes washer, I'm forgetting the word, washing machine filters, but we also have fibers that come off in the dryer, and also when we're just wearing them on a daily basis. So we really need to look at more integrative solutions that are designed into the textiles themselves. How do we create textiles that don't shed, essentially? So a few companies are looking at addressing this. One is this collaboration between Polartec and Houdini, where they're essentially, the way that they're spinning the fabric, that the fleece ends are all on the inside of the jacket. Kind of interesting. I don't know how effective it is. They were saying around 85% less shedding occurring, but what we really need, there's limitless design challenges here in the plastic pollution space. Literally everything that we use that's plastic, we need to reevaluate it. So I want to do another activity with you, and let me see the time. So we're at 8:10. I want to do this activity quickly, and then there's just a few more questions that I want to pose, and then we can do Q&A. So for this activity, I've done this a lot with students, and I've changed it up a little bit for you all in the examples that I've chosen. So we'll see how it goes. But I'm going to be presenting a few different design solutions in this Google slide presentation down here at the bottom that you can click on now. We're going to break you out into breakout rooms, and each group will get to discuss their solution and critique it together. So there's 4 things that I want you to think about. First, of course, identify the innovation, and each one has a brief description and a URL, so you can go and check out the website that's there, or you can do your own research on it. And then I want you to think about a few things, and this is something that I've used a lot personally to help me understand different solutions that are coming out there and thinking about them critically. So the first one is, think about, how does this design help address plastic pollution? It's simple, but I want you to think about it in kind of a broader sense. Is this actually helping us reduce wasteful behavior? Is it helping us use plastics more responsibly or less plastic? Or is it changing the way that we're, our relationship with that product or that part of our culture activity that we do? The second thing is, what are some possible negative consequences that this design solution may have? So this is an exercise in thinking into the future. What would happen if this was a broadly accepted solution, and how would it impact the world and people and communities? And then the third question is, what are questions that you have about this innovation? So starting to think about, how is this going to impact certain environments? Or maybe you want more information that isn't available on the website, or you can't find information about it, and so there needs things that you're worried or concerned about or interested in. And then lastly, anything else that you think about this innovation that you want to share or discuss, and what ifs. What if this was an innovation that was used in a certain context, or what if we changed it this way to improve it? So we're almost done here. I just want to finish up with a few last thoughts. So the first is, I just want to present 3 different questions to think about. We're not going to discuss them now, but I hope that you can take them with you and think about them as you move forward in your career. So the first one is, how can we create a design culture that is more intentional and responsible with the products being put on the shelves, but also with the spaces that we're creating, with the systems that we're designing, etc. I want to just explain this image here, because at first thought, or at first look, uninformed eye might see this and say, oh yeah, perfect, let's reuse that plastic that's in the ocean to make products again. This is a really good example of greenwashing, because and greenwashing isn't a term that we've covered yet today, but is really prevalent in the space that I work in. Greenwashing is where you're essentially marketing your product as more environmentally friendly than it is. And in the case of making products from recycled ocean plastics, this is an example of greenwashing, because it's essentially, it doesn't work. You can collect the plastics from the ocean, which is extremely challenging in the first place, but to actually recycle these plastics doesn't make this new fresh looking bottle on the right here, because that plastic is so degraded by the sun. It actually breaks the plastic polymers down into shorter and shorter pieces, and it becomes very brittle and powdery, and it just breaks and falls apart. And the recycling process, melting that down, does not magically make those polymers grow again and grow in length. And so to make this product on the right, they had to add huge percentage of new plastics, and there's only a small amount of the ocean plastics in there. I'm not even explaining all of the challenges with that, but I just wanted to show or bring in part of the conversation around greenwashing and around being really intentional with true solutions, and how do we, as designers, uphold that integrity within the solutions, which, a lot of this is coming from major brands who are trying to, get public, show a good side or something good that they're doing to help their business. But we really have to be not just critical of these companies, but also help support them actually do things that are truly helping, and not just greenwashing. The second thing that I want to share, and I've talked about this a little bit already, but what I shared today are just a few examples, and there's so many challenges out there that need to be addressed to truly address the plastic issue. So how can we constantly challenge and critique each other to always do better and to build off of each other's ideas in design spaces and outside of them? And then lastly, I just want to talk a little bit about biomimicry and how can we use nature as our design inspiration. Nature has 4 billion years of experience coming up with good solutions that work through a lot of trial and error, I'm sure. These are some of nature's unifying patterns. Nature uses only energy it needs and relies on freely available energy like sunlight. It recycles all materials, it's resilient to disturbances, it optimizes rather than maximizes, etc. The list goes on. And this is something that has been really inspiring for me. And I think if you're not familiar with biomimicry already, this is definitely something to check out, no matter what space you're in, because there's so many different ways that this can be applied, particularly in design. So a few examples are, how might we design our systems so that they are founded in human environment and environmental health? How can we create safe systems instead of ones that are toxic to us and limit the extent of our futures? How might we design our systems so that they are locally attuned and responsive, which is another unifying pattern of nature. Is locally attuned, meaning it's, small scale local reactions that indicate what's happening and how things are moving around, how products are being used, materials are being moved around, etc. And the last example is, how might we design our systems so they provide mutual benefits? How can we solve plastic pollution, but also create a more just society? How can we create ways to get beverages to people and also help malnutrition? There's all sorts of different ways that we can solve multiple problems with the same solutions. And this is something that we see across the board when we're talking about environmental and social problems. So that a lot of times the solutions are one and the same thing, and they solve all these different problems at once. And so I think there's a huge amount of room for diversity of solutions, and for a lot of growth, and huge reason for hope and for looking, to a better future. This is what gets me moving in the morning and keeping this, to continue to work on the work that I do, because I really believe that the solutions that we create, they can be really, really beautiful and much, much better than what we have today, even though what we have today is already, we have so much to be thankful for. So so that's it from me.